Yeah, dear students, we are in continuation with the lecture series of network analysis. So we'll try to do some of the typical problems using mesh analysis. Okay, so this is a problem, a typical problem that is given. So you need to calculate the loop currents. Already the directions are given. So you need to calculate the value of I1, I2, I3, and I4. Okay, so in this problem, first of all, we'll try to understand whether it is belongs to case 1, case 2, or case 3. Okay, usually case 3 is the super mesh concept, right? Whenever a current source is connected, okay, immediately we can understand that it has a super mesh concept. So in this, there is a current source of 2 amperes in the circuit given. So is it a super mesh? No. So it is not the super mesh because this current source is not connected in between two meshes. So very simple. So whenever the current source is not connected in between two meshes, then you cannot consider it as a super mesh concept. And there are no dependent sources in this problem. So this is not case 3 problem. It is not case 2 problem. So it is straightforward case 1 problem. Okay, that means simply we need to apply KVLs in the loops and get the equations. And upon solving them, we will be getting the values of I1, I2, I3, and I4. So going ahead now, so on observation, we clearly understand whenever there is a current source, first you take the advantage of it. That means first you try to keep concentration on that current source. Okay, and directly the loop current you can represent in terms of current source as directly. That means, however, it is not possible to apply KVL in loop 4 is not possible because there is a current source of 2 amperes. If you know the voltage across this 2 amperes, then you can apply it. That is not an issue. But there you don't know the voltage across this 2 amperes. So that is why you cannot apply the KVL. But instead, on observation, directly, you can directly see here, 2 amperes is going up. Okay. And I4 is coming down. So on observation directly, I4 is equal to minus 2 amperes. Though this is equation 1. Okay. So you can take this advantage now for this problem. So going ahead, so applying KVL in loop 1. So I start here. So I walk like this. I walk like this. I walk like this. Okay. So KVL in loop 1. Okay. So this is something 2 times. Okay. Check the currents. Only I1 is a factor, right? So I1 is responsible. And I1 is coming with you. It is your friend. That is why it is plus I1. Okay. Now you crossed this. So now you are entering here. So you are here. 1 ohm. So plus 1. Check the currents now. Current I1 is your friend. But current I2 is coming opposite to you. So that means I1 is your friend. I2 is your enemy. Okay. Then you have crossed this. You have crossed this. You have crossed this. You are here. You are here. You are touching the negative terminal of the battery. Directly it is a voltage now. So take it as minus 4. Then crossing this. And finally you come back to the original position. So which is equal to 0. So that means you rearrange the terms. 3I1 minus I2 is equal to 4. Okay, so this is equation number 2. Now similarly, I will try to apply KVL in loop 2. That means, so I do with this the black color. So start here, you are here, you are here, you are going like this. Okay, any direction you can walk, need not to be worried. But important point is, the current coming with you is your friend. Current coming opposite to you is enemy. So for friend, you take it as positive. For enemy, you take it as negative. So now 4 ohms. Okay. Current is responsible is only I2 for the voltage drop. But I2 is coming opposite to you. Take it as minus. And then plus 1. Okay. Here I1 is your friend. And I2 is your enemy. Okay. Then you have crossed. You are here now. For the 4 ohms. So plus 4. Okay. I2 is your enemy, but I4 is your friend. So minus I2 plus I4. Okay, I2 is coming opposite to you, it is your enemy, but I4 is your friend. Then plus 2 is equal to, this is a voltage drop now directly, voltage drop is equal to 0. So you come back to the original position. Okay, so now going ahead, so I1, now I2 quotients minus 4I2 minus 4I2 8I2 minus 9I2 minus 9I2 plus 2 is equal to 0. Okay, so let me check once again. So I1 quotients I1, I2 quotients minus 4I2 minus I2 minus 4I2 minus 9I2. I3 quotients are not there. Once again you have I4, right? 4I4 is there. So plus 4I4 plus 2 equal to 0. This is equation 3. So this is KVL in loop 2. KVL in loop 1 I have done. KVL in loop 2 I have done. Now I am going for KVL in loop 3. So I will try to consider, I will try to walk, I start walking from here. I walk like this, I walk like this. Okay, so I have a 1 ohm resistor. So however current is coming with you, I3 is with you, take it as positive. You are here, you are here, you are here, and you come back here, you have a voltage source plus 4, then you cross to the source, then once again you are here, so plus 2. Okay, then I3 is with you, so plus I3 is your friend, but I4 is coming opposite to you, so minus I4 is your enemy. Okay, I4 is your enemy, that is by minus 4. Then you come back to the original position is equal to 0. Okay, now 2I3 plus I3, 3I3 minus 2I4 is equal to, how much you are getting it as? Minus 4. Okay, so this is equation number 4. So from this, how many equations? There are 4 equations. How many unknowns? 4 unknown. Straightforward, it is a case 1 problem. So you can solve 1, 2, 3, 4. So for you can solve 1, 2, 3, 4 to get the values of I1, I2, I3 and I4. So I will try to solve it now. So try to substitute equation 1, okay, in 4 directly. That means 3I3 minus 2, I4 is minus 2 na, equal to minus 4. So 3I3, so minus into minus plus 4 equal to minus 4. From this I3 equal to minus 8 by 3 amperes. And I4 already we got it as minus 2 amperes. So you got I3 and I4 now. So once you got I3 and I4, so I think I can take the help of equation 3 here. So equation 3 is in terms of I1, I2 and I4, and here it is equation 2 is in terms of I1 and I4. So now substituting equation 1 in equation 3. Okay, so that means I1 minus 9I2 plus 4I4 is minus 2 plus 2 equal to 0. So from this I1 minus 9I2, okay, so this is minus 8 plus 2 equal to 0. So I1 minus 9I2 is equal to 8 minus 2, that is 6. So now you have equation 2. So multiply equation 2 with 9. Okay, then 27 I1, that means equation 2 with 9. I'm writing here. Okay, 27 I1 minus 9 I2, okay, is equal to, so 9, so this will be 36. So try to subtract these two equations upon solving. So this is minus, this is plus and this is minus. So these two getting cancelled. Okay, so minus 26 I1 equal to minus 30. So I1 equal to 30 by 26 amperes. Okay, so once you got I3, I4 and I1, easily you can calculate I2. So what is the value of I2? I2 you can calculate from equation 2. So from equation 2, okay, so I2 equal to 3I1 minus 4. So from this I2 is equal to 3I1 3 times 30 by 26 minus 4. So 90 by 26 minus 4. So 1, 3. So 45. So 45 minus 52 divided by 13. So this answer is the value of I2. Now we are getting it as 45 minus 52. So minus 7 by 13 amperes. Okay. So in this way you can solve for the values of I1, I2, I3 and I4 because you have perfectly the number of equations as 4 and the number of unknowns are also 4. So that is why it is easily possible to calculate the values of I1, I2, I3 and I4. So once you got the mesh current, even then any voltage drop across the resistor is being asked, or the current in any branch is being asked, or else any power drop is being asked. So any such things are asked, so easily you can try to calculate with the help of this I1, I2, I3 and I4. Okay, so I'm concluding this topic nowadays, students. So methods are most important. So once the methods you apply properly, then the next is simply mathematical analysis. So mathematical solutions. So you can do them very easily. Okay, so thank you for giving this opportunity. So if you really enjoyed the video, just like the video and subscribe the channel. Also, you can comment on it so that it becomes a motivation for us to do a lot more videos. So thank you so much.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.